Hey everyone, I'm Nick. I'm going to talk about lessons learned from working with advanced analytics organizations. I'll say a little bit more of what I mean by that in a second, but just to help me understand folks in the audience, show of hands of people who work with statistical programming languages, Python, R, kind of predictive analytics, not like the, okay, good, work, oh, great, excellent. So what I want you guys to walk away with from this, sort of if I've been successful here, is two things. The first is sort of giving you a sense of some patterns and best practices we've seen from working with companies that I think excel at doing that kind of work. And then the second is more of a strategy for actually implementing some of these ideas in practice, which is different from the theory of it all. So before I get into the specifics, tell you where my perspective on this comes from, and then you can decide whether that makes me credible or not. I run a company called Domino Data Lab. We make a platform for people doing this kind of work for quantitative research teams and data science teams. We work with companies that view advanced analytics as really core to their business, so insurance, financial services, pharma, basically where the quality of the models you're building has a kind of a direct line to revenue. Phone keeps disconnecting. They told me this was going to happen. They told me that I shouldn't use my own computer. Oh, God. Sorry, guys. Okay. So before that, I was at Bridgewater, like Matt alluded to. Bridgewater's a rules-based hedge fund. I built technology there that the quants use to build their macroeconomic models, and then got sort of a background in computer science by educational training. So what I want to go through is like these lessons I mentioned, and just to set expectations, this is not going to be a deep technical talk. This is a little bit more like a conceptual TED Talk style. So the first one, I'll go through these fast. A lot of data scientists think of their work as being sort of a solo act. They're like solo practitioners. But the best organizations we've seen think of their work as contributing to collective knowledge. I've got the beehive here because organizations sort of view themselves as a hive mind, that if one person has worked on something and had some insight, how do we make sure that the rest of the organization has that as well? And not just today, but also over time. So as people turn over, that knowledge is sort of preserved. You're contributing to a collective whole. Next one, we see a lot of people, some individual practitioners, with this model that research gets pushed forward through these aha moments or epiphanies. But really what happens is that progress actually comes from lots of little insights that compound over time. And I've got this picture here of the classic myth is that Isaac Newton was sitting under the apple tree and the apple fell and he had this epiphany about gravity. But actually Newton said, if I've seen farther than others, it's by standing on the shoulders of giants. So how does an organization make sure that as these little insights are happening, that they're compounding and that people are building on top of them? Next kind of lesson or myth I'll talk about is a lot of organizations that are out looking for silver bullet tools, visualization tool, next big data technology, new packaged machine learning algorithm in a box. And in reality, what we see is that there's sort of a meta thing on top of that, which is not one particular tool. That's never the answer. It's much more about having agility to let people rapidly experiment with whatever the next thing is that comes out, and to not get stifled or sort of bottlenecked by maybe internal IT processes to have that agility. And then the final thing the final sort of myth and lesson I'll talk about, and then I'll step back a bit, is we see a lot of folks, kind of especially at the senior level, the sort of leadership that thinks we'll just bring in some new technology and that'll make all the difference. So it's a little bit related to that point about one silver bullet tool. But this is more of a critique about the whole notion that technology itself is a solution. And I liked what Ashish said. I think that you got to think about people, process, and technology working together. So what we see is that really making progress in doing this kind of advanced analytics work comes from having a culture of discipline around some of the things I mentioned earlier. How are we making sure that our insights are compounding? How are we making sure that we're contributing to collective knowledge? And so it's having a culture of sort of discipline, collaboration, and viewing an organization's work as this constant making incremental progress. And so the best that we think you can hope for with technology is to facilitate that, not to be kind of a panacea. So taking a step back from that, I just wanted to characterize a couple themes. Now I'm transitioning to something a little bit more concrete. The timer's not running. I don't know if anyone. So.
We now have 15 minutes.
Lucky me. So the first thing that kind of cuts across a lot of what I described is around collaboration, and how do companies make sure that when they're doing this kind of work that they're preserving shared context, that they're creating shared context, especially with distributed teams. If a group is working on a project together and some people are in different parts of the world or the country, how do you make sure that people aren't reinventing the wheel because they didn't know what other people had tried? Preserving discussion around all that is important as well. And then it's not just a matter of preserving it, but making it discoverable and accessible. So if someone starts a new project, how can they find what's been done in the organization before so they don't start from scratch? Next kind of thematic area is around reproducibility and reusability. And what we've learned is that for this kind of work, this advanced analytics, quantitative research work, reproducibility is more than just, hey, we have a snapshot of the code. It's great for software engineering. GitHub does that really well. What we found is that if you actually want to reproduce what you did in some of these quantitative research experiments, you might need the data sets as well. You really want the results as well, not just sort of the source code you ran, because you're not building a binary artifact. You're building a results of some analysis and rock curves or whatever. You also need the environment in which it ran. What were the versions of packages you had? What version of R was deployed? Because if you don't have that, then yeah, you can check out the source code again, but you can't actually reuse it. You can't actually reproduce the result. We didn't have this in mind when we started building the product that we've got, but one of the really interesting things about reproducibility we've learned is that it's been extremely resonant in industries where there are regulatory and compliance concerns. And we're sort of seeing that more and more, especially in financial services, that are becoming attuned to, hey, gosh, regulators could come in and ask why we built that model, and now they're actually starting to look at code, and can we really answer questions like that? So insurance, financial services, pharma. And then the final sort of thematic area is around agility. And I mean this in two ways. One is sort of experimentation agility, letting data scientists and quant researchers try new tools, run lots of experiments easily. Part of that gets at sort of accessibility of scalable compute resources. But the other part is around deployment agility. And okay, if you've actually built something that works, how quickly can you get it out into the business? Because that creates the feedback loop that creates credibility and buy-in to continue sort of investing in the work that's going on. So I want to do a really quick demo of kind of the way we've approached solving this. To motivate that, I just want to describe kind of the strategy we've taken. And if you look at those themes and the kind of the lessons I've been describing, what's interesting is some of them are relevant to sort of individual contributors. Data scientists want to be able to run lots of experiments and have flexibility of what packages they're using. And some of them are more from an organizational perspective. How do we make sure that everyone's work is preserved, that we're compounding knowledge? So the way we've approached this is to say, look, let's give individual researchers something that they want. It's like the cupcake. And what we think those people seem to want is the ability to test more ideas faster, that experimental agility, some ways to sort of expose their work more out into the business. But let's package that in a way that automates or incentivizes best practices. And so in particular, the drawing's a little subtle, the illustration's a little subtle, but that's supposed to be medicine and pills on the cupcake, so tricking people into thinking it's sprinkles. And so anyway, so package up that sort of productivity boost with something that makes it so people inevitably just work in a way that gives them these best practices like reproducibility and collaboration. So let me show you quickly how that works. And I really just mean this sort of as a proof of concept of that slide. I'm not going to, there's a big surface area to the product. So because we're at Bloomberg in New York, I'll do a finance example. So let's say we're working on a project and we're developing a trading strategy, and I've got some code in Python, and I've got my script here. So it's plain Python code. There's sort of nothing special about it. Let's say I've written this, and now I want to try running a couple different variations of a simulation. I've got my machine, it's got 8 cores, that's sort of fine. Well, I want to scale this up. And so what I can do is I can pick, these are Amazon hardware tiers, though this can also run on premise, but Amazon now has a 128 core, 2 terabyte of RAM machine. Maybe I want to try that for the demo. I'm going to use a small machine. The other thing I can do, though, is I can set up a compute environment. These are totally customizable. We use Docker under the hood. So basically, data scientists can just install whatever packages they want, not affect anything else, not affect production. And then I can say, I'm going to fire up a couple versions of this experiment. I'm going to try, this thing is wired to take a parameter. It's like how long of a window size to use for moving average calculations or something. It's sort of contrived. So anyway, I'm going to fire that off. But in parallel, I want to try maybe a different parameter. So I'm going to fire that off, too. So we're spinning up 2 machines now of whatever hardware type you pick, so maybe 2 X1 instances. We're going to run these experiments in parallel. This will take a minute. Maybe while that's going, though, I'm sort of interested in playing around. So I'm going to fire up a Jupyter Notebook. Do the same thing. We'll sort of spin up a new machine. And it'll sort of take a second to start. And then when it's ready, drop me into it. But what it does is it sort of mounts in all my files, make sure my environment's set up properly. And all right. So every time one of these things runs, we keep, this is like the agility, instant gratification for the analysts, right? They like the power of accessing the big machines. Every time one of these runs, though, I'll show you what I mean by the, there's my Jupyter Notebook. By sort of automating best practices, because we're controlling the execution infrastructure here, we keep records of everything that happens. So this is sort of my experimental history of what I've tried in the past, going back through time. And when these experiments finish up, you'll see we preserve the results that get generated. So, structured statistics like my Sharpe ratio from a back test. We'll capture graphical results like plots that I produced. And one of the things that lets us do is this is now sort of a central point where I can have a discussion. My colleagues can get notifications about what's happening here. What's with the double dip? And so that sort of preserves knowledge, context about what's going on as these experiments happen. And then to just kind of underscore the power of that, I can do things like, I tried a couple different variations of this. I'm actually not sure how they compare relative to each other, so I can sort of pull them up side by side and see differences, not merely in terms of source code that I ran, but also in terms of results. So result space, not just input space. And then if we kind of zoom out, imagine I leave the project, maybe it's dormant for 6 months, someone new comes on board, they're sort of wondering if we've done research about a certain topic, have we done anything trying out the Pyfolio package? All right, I can search, I've got my files indexed here, so I can find where that might be used. Maybe I'm sort of wondering if we've ever looked into double dips in performance charts, in P&L charts. And so I can actually find, oh yeah, where did we ever look at that? And so here's the particular comment on the particular revision of this P&L chart, and we have the lineage back to, oh well, it was this exact experiment that ran on October 26th with that particular parameter and this particular snapshot of all the work I did. And so all that knowledge isn't lost to sort of the winds of time. So anyway, that's sort of like the couple-minute boiled-down essence of our view of how you can combine sort of productivity and agility for individuals in a way that facilitates these best practices of organizations. So you're compounding knowledge, you're enabling collaboration, and then over time, you're dramatically accelerating the pace at which research happens in an organization.
A demo that actually worked, and especially through the world-renowned Bloomberg firewall, which is very, very impressive, among other things. Zurek, what else? You mentioned a broad surface area. What else does a product do that you can talk about?
Yeah. So the way we think about I like to describe the analytical life cycle, which I view as going from sort of early exploration and ideation, and so we support a number of interactive workspaces like you saw briefly, Jupyter Notebooks, RStudio, Zeppelin, so spinning those up on remote, more powerful hardware through our reproducibility engine that I showed you. The next phase I think of is sort of experimentation, and so that's mainly what I showed here. How can you run a lot of experiments, keep them tracked? And then the final phase is productionization or operationalization. How do you take what you built and get it exposed out of the business? So we support that in a few ways. You can deploy models as APIs for integration into production automated systems. You can wrap models you've built in lightweight web forms so that human consumers can interact with them without bothering a quant. We support kind of app hosting, Shiny, Flask apps, things like that. And so that's sort of the life cycle of a particular piece of research. Then, sitting underneath that is all this stuff around collaboration, preserving organizational knowledge. And so I think I briefly touched on that: commenting, discussion, search, knowledge management.
And since you connect a lot of pieces, any kind of interesting insight about sort of emerging trends in the data science toolkit? So, Zeppelin versus Jupyter, for example, or what do you think that surprised you in terms of what data scientists want?
Probably the most, well, I don't know whether it's surprising or not. I think there's still more hype around Spark than actual value extraction from it. You hear a lot of people sort of, does this support Spark? Can you integrate with Spark? And we say, yes. Or and then they ask, well, how? And we say, well, what's your Spark cluster like today? Are you actually using it? No. It's just something we're thinking about. We got a lot of that. The other trend, it's not data science tooling, but to echo something that Ashish said, we see a lot more of the Fortune 1000 interested in the cloud, and it's sort of a slower moving thing, but we see a lot of folks wanting to use VPC environments. So they're comfortable with AWS. They'd rather it be like their VPC, but moving in that direction pretty inescapably, I think.
Do we have questions? Get a mic somewhere.
I have a set of questions about your presentation. The first one is, you said that there is no silver bullet for solving every task, and that's true, but previous presenter said that data become bigger because of consolidation of different data. And you said that there are different tools. So do you have any algorithm how to determine whether some piece of data should be separated or aggregated? That's the first one. And another two are about versioning data. I think the second is more interesting for me. How do you versioning data and process real-time data? Thanks.
Sure. So we revision files, and we revision large files. And by large, I mean tens of gigabytes, maybe sort of 50 to 100 gigabytes. I don't mean terabytes. I don't mean petabytes. And so what we do is we can snapshot and preserve records of those files. If your data lives in file, we see lots of big CSV files, that's fine. If you're sourcing your data, when you run code, if you're sourcing it from data sources, you suck it in from a database or from a HDFS cluster or whatever. If it's important for you to keep a record of it, you can write it out to a file when your code's running, and we'll revision that as a file, so you can get back to exactly what data you sourced. Yeah.
Great presentation, and I really like the whole collaboration focus. I'm interested, though, within financial institutions, many times there are walls in terms that have to be observed between what kind of analytics, what kind of data. So does the platform actually manage those kind of separations, or in practice, you end up setting up separate platforms?
I'm sort of trying to make sure I understand the question, because it's interesting. We've seen that in government, but I'm not sure we've actually run into that in financial services yet. Maybe.
Between sales and trading, for example.
Yeah, there's probably some selection bias in who tends to be interested in what we're doing. I think that the folks who are doing sufficiently sophisticated work to really want to use what we're doing tend to be in groups where they don't have those restrictions. So quant research group. We haven't bumped into that yet. Sorry, that's not a very satisfying answer, but.
Over there.
Yeah, I love this, and this makes a ton of sense for people who are being shoehorned into using other knowledge sharing systems like Jira or other wiki software right now. Do you find that people who are not natively working with data then end up adopting the platform as well, or are there sort of distinct? Do you see there being distinct disciplines within companies where really Domino's knowledge share platform wouldn't apply to people who are not working in data models or data intensive work on a daily basis?
It's not an area we've really spent any time focused on right now. We've been really focused on the sort of data scientist, quantitative researcher persona, and we sort of have people at companies who just want to throw their Excel files in here, or throw their PowerPoint files in here, and they see it as a simplified, dumbed down version control. We're not going to tell someone not to do that, but it's really not the thing for us. And I think given our background and the problems we're excited about, we think the unique thing that we can bring to the market is what is different about collaboration in a quantitative research context, not collaboration generally, right? Because someone can ask a question like, well, why do software engineers need GitHub when there's SharePoint? SharePoint is a collaboration tool. You can track versions of files. Our thesis is that there's something specific and different about quantitative research workflows that warrant their own sort of specialized product.
Great. One last question here. Was there one over there? Okay. No, you're good at, since you've been such a kind. No, you can go ahead. I thought there was somebody else.
Sure.
Since there isn't, please.
Okay, thanks a lot. So there's an awful lot of literature and discussion around problems of reproducibility in science.
Yep.
Obviously, your platform speaks to that need.
Yep.
Do you see that as a big business driver and a big, sort of thematic need out there?
Increasingly, we do. It's funny, when we started, reproducibility was built into the product from the beginning from our experience, again, at Bridgewater, where we'd seen that immutability and accessibility of past results to be a research accelerator. So we saw it as something that, as a best practice, you will actually progress faster if you're working this way. And then we actually started taking the product to market and selling it. We sort of bumped into people interested in it for regulatory purposes, like I mentioned. And so pharma, insurance, where they're actually very concerned about being able to answer questions for regulators. And so that, from a go-to-market perspective, that's been great to experience. It wasn't something we intended, but it's working out well. People buy products to reduce costs, increase revenue, or stay out of jail, and we're trying to hit as many of those as we can. Yeah.
All right, wonderful. Thank you so
Thanks,
much.
man.
I appreciate it.